As promised, I'm going to find the inverse of this function as an extra example to help you through your homework. The first thing we always want to do is that horizontal line test. So we want to take a look at the graph. This is a function that we haven't talked about how to graph just yet. And so if you get a function like this that you don't know what the graph looks like on homework, you can certainly take a look in Desmos. If I put one like this on an exam, I will give you the graph so you can check the horizontal line test. But let's hop over to Desmos. I have it graphed. All right, so here's the graph of x minus 1 over x plus 2. And the horizontal line test, it looks like it passes the horizontal line test. It's kind of a crazy looking graph. But even the parts that are starting to get flatter as it goes out towards the right and left-hand side, they look like they're still a bit on an angle. So this is going to pass the horizontal line test. All right, so that means that the f of x is 1 to 1. It means it will have an inverse. So we're going to do our second step, which is where we replace f of x with y. And then we're going to swap x and y values. And then we want to solve for y. And the reason why this one's a bit trickier than the ones that we did in class is you've got two values of y to solve for. What we're going to want to do is to multiply both sides by that denominator y plus 2. So I'm going to multiply on both sides by y plus 2. And that's going to cancel out the fraction on the right. So let's see what we have left once I do that. So I'm going to have x times y plus 2 equals y minus 1. So now I want to get all of my y's by themselves on one side of the equation, everything else on the other side. And to do that, I want to liberate this y over on the left from its set of parentheses. So I'm going to distribute the x so that I don't need those parentheses anymore. And that's going to give me x times y plus 2x equals y minus 1. I'm going to subtract xy from both sides. And I'm also going to add 1 to both sides to get that 1 off of the right-hand side. So that's going to leave me with all of my y terms over on the right and all of my non-y terms over on the left. So I've got 2x plus 1 over on the left, and I've got y minus xy over on the right. And here's where I wanted to show you a trick. I've got two y's over there on the right-hand side, but I want to be able to solve for y to just have one y. So if you get something that looks like this, your trick is to factor. So I'm going to factor a y on the right-hand side. I still have 2x plus 1 on the left. I'm going to factor a y out of both terms on the right. And that leaves me with a 1 minus x. And then to solve for y, I can just divide both sides by 1 minus x. And that gives me 2x plus 1 over 1 minus x equals y. And since I'm done solving, this is my inverse function, I'm going to go ahead and do that step 5, where I change that into an f inverse of x. And that's our inverse function.